Hey, what's going on, folks? It's Mike here, and welcome back to my Deep Programming Language series. In today's episode, we're going to continue talking about classes, but this time talking about specifically interfaces, which is a tool which helps us, well, program to an interface. And not only can we program to an interface, but we can have a sort of common component or common object type where things are adhering to some type of interface. So we'll go ahead and look at a few examples, but let's go ahead and start with just what a interface is. So I'm going to go ahead and first take us to the Learn page here, because again, this is something that you'll find in the D Basics section here with interfaces. And you'll find a nice example here with sort of the classic, like, let's create an interface for things that are animals, for instance. And a few different observations here, which I also like to follow. One is putting a capital I in front of animal, just to be clear that this is an interface. And this is one sort of coding style thing that I tend to adhere to. You'll see this in other languages as well. And I actually just like it because it just, again, communicates very quickly that this is an interface for some common type here. So this idea of having a common interface is also related to stuff we've been talking about with classes. That's why I've kind of filed it under this section of classes here, even though an interface might be its own topic here. But let's go ahead and just zoom in on an interface, and then we'll go ahead and look at the interface page on the Deep Programming Language website. But this is the basic idea here. So you have an interface, and then you have whatever you're going to name it, again, usually with some capital I at the front, and then you have your member functions here. Now, these member functions here are basically virtual functions that you're going to implement. As you can see, there's no implementation here. There's no curly braces. There's no body of the function here that does any work. And that's the idea of an interface. We program to an interface. So the interface truly serves as a blueprint, and then you implement a class from this interface. So if we continue looking at this example, we can see that, for instance, we have a new class for our dog and our interface that we are implementing from here. And we can read this as implement. Some languages will use like a keyword for implement. I mean, so this kind of looks like inheritance, which we've looked at before. But again, if I pass in some interface here, something with a capital I as we've named it, then we are implementing these functions here. Okay, so that's the basic idea here. And if it's useful, we'll just go ahead and draw this example out briefly for what we've just seen here, where I've got my animal interface. And let's just go ahead and put the I animal here. And again, I have something like make noise. And that's what I have to implement. So somewhere else, I'll create my class here, dog. And if it implements this interface, I animal, you could effectively think of it as I need to wire up the make noise function, sort of like where we talked about virtual tables here, to this function here, okay, so that it makes the right call. And then I could, create other classes, for instance, like husky, for instance, which could be a type of dog. And it would take make noise if we haven't implemented that, or I could, again, override this implementation by providing my own make noise function here. Okay, for a husky or a golden retriever or whatever type of dog you could think of that is also of this type dog here. So it is important to note, though, that this also does form an inheritance chain. So again, a dog is a type of animal. A husky is a type of dog. A husky is also a type of animal here. Okay, so hopefully that kind of just visualizes what's going on. You can think of an interface, if it's easy for you, as basically a class with no implementation. But again, it's enforcing some rule or a contract where you must implement functions. So let's just go ahead and write that out here. So interface is like a contract where we must implement the member functions, or just the functionality in general. Functionality. Okay, by which I mean member functions. So there's no member fields here. You'll notice there isn't like a integer for like, hunger or something, or, volume, or, whatever noise you want animal to make here. There are no members here, just functionality. And that is the idea here. Okay, so let's go ahead and play around with this. And again, just get some intuition as to how we can use interfaces. And I also want to take you to the Deep Programming Language website here, language references. And let's just go ahead and approach this again from a little bit of a different angle here from the Learn page, although the Learn page is quite nice here. I am going to show you one other thing that shows up on the Learn page here with Final. You will notice there is an exception to what I just told you an interface was, where if I have non-virtual functions, I can add a implementation. But let's leave that as a little surprise here, and let's work from the interfaces page here and just do a little bit of example coding ourselves here. Okay, so again, an interface describes a list of functions that a class which inherits from the interface must implement. Okay, so that's the idea. We've seen the syntax here. Now we are allowed to have multiple interfaces from which we build our class from. So for instance, if I want to have an animal here, and then let's create another interface on this side here, and I don't know, let's just call it like 4 legs or something. So interface, let's see, 4 legs. Sorry, I'm calling it kind of a weird thing. And I don't know, maybe we have something like run, some sort of function like that. It is possible to, again, have dog and then also have 4 legs here. Another interface, 4 legs. Okay. Oops, I'm just kind of tacking that on there. But this means in D we can have, so let me just add to my notes here and then we'll show it in code as I highlight a few things. Let me just give a box here. Multiple interfaces are allowed. Multiple inheritance is not allowed. Okay, so I'm just going to strike it out there. Okay, so what that means is I can have a dog derive as many interfaces as I want, but I can't have a dog derive from other classes. Okay, I can derive from multiple interfaces, no problem, but that's the idea here. Okay, so that's the basic idea here. And then it says, again, a class that implements an interface can be implicitly converted to a reference to that interface. Now, why is this important? Well, that's going to come up with the various use cases for why we might want a interface itself, okay, which I'll touch on. But let's go ahead and do a few examples here. Let's go ahead and just work with that animal example for now. And we'll work with like make noise. I tend to make my functions uppercase here. And then I have my class dog here, for instance, and let's implement animal here. Okay, let's just try to compile this example to see what's going to happen here. We are going to get an error message, right? Because again, this is my contract, this interface here, and it's saying, hey, error class, in this module main, the file name dog, the interface function void make noise is not implemented, right? And we're promising, right, that the dog is going to implement this interface here. Okay, so let's go ahead and add in make noise. So the same function here. And I'll write line making a noise. Let's go ahead and give this a try. Let's see if this works here. This does work here. Okay, so this is fine. Now, if we do inheritance and these type of things here, we learned before that we needed to put override here. And we can also put it here. There's no problem. But generally speaking, at the top level, you just don't need to do it here, right? You could assume that you're implementing this interface, right? It's right here in front of you, so no problem here. So anyways, let's go ahead and have our dog. I'm going to say my dog equals new because this is a class dog here. And let's do my dog dot make noise, and let's go ahead and run this, and you can see making a noise here. Now, just to make this a little bit more specific, let's just go ahead and put the fully qualified name. So the module, which is usually the file type, unless we explicitly specify the module, which we haven't learned about yet. But let's just go ahead and do this, just so we know that this is what's being called here. main.dog.make noise. Okay. Okay. So let's go ahead and show the example that we drew out here. And let's go ahead and create another class here, Husky, which will implement from dog. And let's go ahead and make a new Husky here, okay? Or pick your favorite type of dog. And let's go ahead and try dog, my husky equals new husky, and I'll do my husky dot make noise. Okay, just so we start keeping track of things, and let's try to think for a moment which function is actually going to be called here. Okay, so again, my husky, and it doesn't have this implemented here, but I am inheriting from dog, so let's go ahead and see if I run this. This is okay, right? We're calling into this make noise function. But let's go ahead and implement make noise, okay, for our husky. And I'll go ahead and pop this in here. And let's go ahead and update. So this is not dog, this is husky, just so we can see what's being called. And let's see what ends up getting called here. Well, it's going to say, again, an error message. Again, this is what I was hinting at before here. It says, cannot implicitly override base class method main.dog make noise with main.husky make noise, add override attribute. Okay, so this is where the override attribute is important because we are lower in the chain. So I do need to override and make sure that because I'm instantiating, I mean, both of these I listed as dog, right? A husky is a type of dog. Dog is just a dog here. And then I want to make the noise here. Okay, so let's go ahead and run it here. Okay, so now we can see the proper functions are being called. The first one for the dog and the next one for the husky here. Okay, so no problem here. Now here's a question here. Can I do something like new animal here? And let's just think about it. Let's think about, I mean, what would this be instantiating as an animal, right? This interface, think about this. Is there any memory here? Okay, so let's try to run this and see if it does anything. No, right? We can't create an instance of a animal in this sort of way, right? It doesn't really make sense. Because again, this isn't really a concrete type. This is a contract that's saying, hey, this is how you, dogs must do this thing. Now the dog is the actual thing that you instantiate, whether it's the dog or the husky, okay? So we can't do that on this side. And again, new is what's giving us the memory, enough memory for the dog object. Husky is what's giving us enough memory for the dog object. So what if I did this though on the other side, animal, okay? And then I could do animal. And then now if I run this, well, again, this is just following the inheritance hierarchy. A dog is a type of animal. And we'll figure out at compile time which one we want to instantiate with new here. Let's go ahead and run this. And this works here, okay? So this is actually a really powerful idea here that we're able to just say, hey, I can have a bunch of things that are, you know, adhering to animal. You can kind of think of this as like the top of your inheritance chain here. So then I can have, you know, each of these dog and husky here. So let's make this just a little bit more interesting here. And now let's say I want a dynamic array here, and let's just call my animals here. And let's add my animals, add my dog. And let's add my animals. So I'm just going to append to this my husky. And there's a couple of different ways we could do this, right? We could also do this as like, we could put my dog and then my husky this way too, right? Let's do that. That's a little bit more concise. Okay, so that works. And now let's just do for each, I don't know, dog in my animals. Let's go ahead and say dog, make noise. Okay, so now we have this collection here. Now again, this collection is referring to these objects, right? So there's some sharing going on. So don't forget about classes being reference types here. So the same objects, but then we should get the same behavior, right? Where I added my dog first and we'll get the dog sound and then my husky, right? So we're gonna repeat this twice effectively. And I'll put a little right line here just to put a little bit of spacing. But yeah, now we can see that we're iterating through our collection here, like animal. Okay, so here's our dog, here's a husky. And again, this is the power of having a common interface here. Okay, so that gives us most of the syntax we have here. And then the last example is just to go ahead and show that we can have multiple interfaces. So I don't know, I came up with like 4 legs or something, and then maybe you can run, something like that. And so a dog could, for instance, have and let's begin these with capital I here. I for legs like this. So now dog should be implementing the animal and 4 legs here. Okay. So what's going on here? Well, now again, we need to implement run. Okay. And I'm just going to say, let's override run here, just so we have it. And this still works here. Okay. Now you can imagine as I start having multiple interfaces, things get a little bit complicated because, well, then we might say, you know, would this have worked? What if I did I 4 legs here? Okay, let's go ahead and complete that here. And then we're going to get this, you know, issue here where we do have to be a little bit careful here. Now these are iAnimal, but let's try to fix this here. Let's see if this will just compile. And then we can decide if it does, you know, the right things here. I 4 legs. Okay, so I mean, it can become a little bit messy as you start to branch. I mean, this is one of the reasons why you can have multiple interfaces, but when you start to get multiple sort of branches, things can get a little bit complicated. So even though this is supported and this is better than having multiple interface, I tend to only have one sort of interface that I adhere to. Again, this just kind of works nice here. So anyways, let's look through the rest of this here, see if there's anything else we should cover. So we talked about this. Yeah, obviously you can't have duplicate interfaces. That doesn't really make sense here. All right, and here we go. So we are able to, if we eliminate for our interface, right, when I just put in this sort of function here, right, this is going to cause an error because, again, this is a virtual function that we're effectively going to override. That's sort of the contract we have. But we can put these types of functions here, which we talked about last time, like static, so that's shared amongst everything that's a dog, and then a final function as well here. Okay, so that could be fine here. So one thing that I might do here, let's get rid of this interface now in this instance here. So for the 4 legs, and let's just say, okay, we want to be able to run, and you know, if I want to provide, instead of just having sort of this empty implementation here, let's just do a final void function run, and let's just go ahead and print we are running. Okay, and that is fine. Oops, that if I type that right, there we go. Now we can compile here, right? So this is one instance where you can have this implementation here. And you could do something, and this is what the DLang page does, which is kind of neat, or where you might use this sort of pattern here. Let's scroll down, right? So you have your final function here, which could be part of the interface, and then that can do something like call into these functions that are going to be overridden and do the right behavior, okay? So hopefully that makes sense here in this context, right? Make noise is what each individual you know, class that we create is going to implement, but then I could use that in this final function here. So we are running, and then I could call, you know, make noise here. Okay, so let's go ahead and just, let's do that in our loop just so we have something new here. So for each dog, we'll call run, and we'll run our program. And here we are running, make a noise from the dog. We are running, make a noise from the husky here. Okay, so that's one thing that you can do here. And then that's per instance, you'll have that final function. And again, we learned that final was a way to also get rid of virtual calls. And then, of course, you have static, which would be just shared amongst every thing that has this interface here. So if you wanted to do some bookkeeping or something, you could have a static member function there. Let's see here. Oh, the other thing is if you have, say, a templated function, that is implicitly like a final member function because that's effectively shared, right? So this is okay here, okay, because we've added those template arguments here. Okay, so just something to keep in mind here. And again, if you do choose to wander into these corners and use like static and final, right, you're not going to be able to override those functions, right, because they are in fact final and static. Okay, so there's only one that you get here. Okay, let's see if there was anything else here from the spec that we would like to see. Let's scroll down here. We've got some ways to re-implement part of the interface, which we've talked about with override here. So again, when you have a deeper hierarchy, so we've already looked at that. Okay, so I think that's pretty much it. We haven't talked about contracts, but all these things in regards to various contracts that are supported in the language can also be applied to interfaces, which is pretty cool here. So you can have some assertions on the input parameters here, which is pretty neat here. There are some other important notes here about interfacing with C++, for instance. D is a great language for interfacing with the C++ language. It's one of the few that can do it pretty well, as far as I recall. And we'll talk about that later on in this series when it becomes a little bit more important, just as a sort of a special topic. But there's a few examples in here, for instance, that are used. And then we'll talk about abstract classes coming up here. And here is the section on C++ interfaces. So you can kind of see how if you've done some C++, the interface would map to something that's like virtual void. Again, so this is actually a really important tool in the deprogramming language to have this functionality for your interfaces and to see how it maps to the C++ syntax down here. So very, it's pretty clean. I actually like how D deals with this. So the last thing that I want to talk about or show you briefly here is just, a use case of interfaces that I really like. One, if you have these sort of things like an interface for, some type like this, an animal or something, that's not a bad idea. I do like using interface for like a container though, or a, data structure, any data structure. And that way you can have things like, push, pop, okay, and maybe pop returns the type, so you can template the interface here for the return type. And then you would implement for the class here, let's do like, things that push and pop here, like a stack. And let's have it do this container. So this is going to be an interface, I container. Let's see, how do we do this here? Well, this is templated, so we're probably going to get some syntax error here. So it's templated. Where do we put that T? Do we put it here? Let's go ahead and see here. Nope, not quite. We go ahead and put it. Let's move it, to our stack. Let's implement push, pop. Okay, and that should be okay. Let's actually instantiate push and pop to do something interesting. Let's see here. Let's just put it at the top of our main here. Let's do a stack of int s equals, stack of, I don't know, int something like that. Oops, let's see if I did that right. Oh, almost. It's not one or the other. It's both there. There we go. Okay. And I think I just need to add a exclamation point there. There we go. And actually then just implement pop correctly, or I return, I don't know, let's just do a t temp, and then I just return temp there. I don't know, just so it's doing something here. And then at line 41, what am I doing here? New, because it's a class. Okay, so let me just go ahead and show you the full thing here. I wasn't expecting to go and all that, but there we go. So anyways, this is a way that you could use interfaces with containers, get all the syntax and showing stuff working as we go there. So you can have a container type, like for a data structure, for instance, and then you could template it for whatever data that you're working with, and then have something like this, a stack or something. And then you could go ahead and see that we could say, well, let's go ahead and duplicate this. Sorry, let's push this one more further, and let's go ahead and maybe have a queue, or a stack based off a linked list, or a stack based off of an array, or whatever you want here. But then you can see now we've got the two implementations here, and we can do kind of the same trick here, where we just say, hey, let's have some type of stack here. And then we could do, let's just do s.push, s.pop. Okay. So, it does something. And then later on, you can say, well, actually, I didn't want a stack, so I'm going to change this to, a queue. and it adheres to the same interface. So, we could just recompile and quickly in one line, refactor and swap that data structure out. And then the same things that we saw before, where I could have a container of containers. So if you wanted a container of stacks and a container of queues and so on, you could do the same trick that we did with our animals down here, where then you can have collections of these containers or whatever. You just, so again, you get the same sort of benefits there if you want here. But again, this allows you to program to a common interface. This is probably the most common thing that I use interfaces for. So I just wanted to show you that. But otherwise, we still have this nice example here with animals. You can have multiple interfaces as we explored, but again, I tend to stick to just one most of the time. You can have contracts, you can have final functions as we showed here, so you don't have to override them, but you can use some of the specific behavior for each type here. And then, of course, you've still got your inheritance as you need here. All right, so that pretty much covers interfaces. They're a really powerful tool. They're a nice tool. I like programming to interfaces. Now, I guess the one last thing to think about is, can I use a struct with an interface? So again, you got to kind of put your thinking cap on, and let's go ahead and try it. I mean, that's the other reason to just figure out. So let's go ahead and say, I don't know, some other, a cat, for instance. And can a cat be part of the interface club here? Let's try to compile it. No. Okay, error. Base classes are not allowed for struct. Did you mean, I mean, it's just giving us some sort of bogus thing here. But because of struct, there's no inheritance, right? And this is using inheritance, can't use it. So just a little bit of a review from way back, a few previous lessons where we talked about the difference between a struct and a class. If that's not clear, go back in the playlist and watch a few of those videos. But remember, struct, since you can't have any inheritance, there's no reason to really program to a contract. The interface is exactly what the struct is. Okay, so that's sort of the way that I think about it. Okay, so just so you don't get confused with that there. Okay, so at least the built-in or trivial way to use a struct doesn't allow for this sort of programming to an interface as we just saw there. So anyways, folks, with that said, hopefully that was an interesting lesson on interfaces. If you want to catch up on all the class videos here, again, I'll take you to courses.msha.io. You can go ahead and track your progress here on the same videos that you're watching, just in a environment where you can, track your progress and kind of keep up with what's going on in this playlist. But with that said, folks, again, let me know if you have other uses where you like interfaces. If you're using the contract features with interfaces, I'd be curious to see examples anywhere on the comment sections or discussion on courses.msha.io. And as always, thanks for your time and attention. I'll look forward to otherwise seeing you in the next one.